of all the different pieces of the Guardian platform, basically everything you need to establish proper security. And before we dig into the individual pieces, an important thread that we'll see in this demonstration is the establishment of trust among the components of the medical device. So even with cryptography turned on, with a library like OpenSSL, and data being encrypted, signed, and authenticated cryptographically, it doesn't mean the device is actually operating securely. And we'll see that in a little bit here. Proper trust is required to enable security that satisfies the FDA cybersecurity guidance for medical devices. So in this infrastructure here for the Guardian platform, in order to properly secure a device in this manner, we need to establish that trust of the cryptographic keys in the medical device. And the medical Guardian or the Medcrypt Guardian solution provides the necessary infrastructure and tooling to make it easy for engineers to establish that cryptographic security with the trusted keys in their medical device. So the Medcrypt Guardian solution covers the gaps that engineers typically encounter with other partial solutions. For instance, solutions from well-known certificate authorities, PKI vendors, cryptography library providers. There are a lot of pieces that are missing to do this end-to-end in an easy fashion. So out of the box, on the infrastructure here, for Guardian Cloud, we can see that Medcrypt provides private certificate authority backed by FIPS compliant HSMs, a PKI or public key infrastructure and key and certificate management, a device provisioning workflow system to centrally process CSRs and track and manage devices and their certificates. And then on the device side, right, there are two pieces to this. There's all the infrastructure you need to facilitate the trust, the root of trust, and all of the CSR processing. And then on the device side, you need some sort of cryptography library and you need to generate your keys and everything. So on the device side, we have a cryptography abstraction library called the Guardian Library. And that's used in the device to generate the correct key material, secure the keys on the device, generate CSRs and other device metadata to enable the device provisioning workflow to acquire certificates, manage key rotation and certificate renewal, and then provide a simple, stable API to deal with the cryptography operations to secure device data and communications. So the Medcrypt Guardian solution is a profile-driven cryptography abstraction. So engineers don't have to worry about setting up and maintaining all of this infrastructure or interfacing with crypto libraries, hardware, OpenSSL, WolfSSL, Libsodium, HSMs, or crypto elements. That's all abstracted and handled by the Guardian ecosystem.